Next, we have SURDS in fractions. We're dealing with addition and subtractions first. Let's say we have 5 over root 2 plus 3 over root 3. It's just the same thing as adding fractions. Let's say, for example, you have 1 over 2 plus 2 over 3. The first thing you do is find the LCM. LCM of 2 and 3 is 6. Same applies to when you're working with SURDS. Sometimes finding the LCM is just by multiplying the denominators, the numbers at the bottom. Here, we just multiply the roots at the bottom. So we have root 2 times root 3. You can have it as root 2 times root 3. It gives you root 6. You should be very good with multiplying your SURDS now. So we have the LCM of root 2 and root 3 as root 6. Now we divide root 6 by root 2. You know our division. You can just simply have it as root 6 divided by root 2. 2 into 1, 2 in 6, that's 3. We now have it as root 3 over root 1. Note, the roots don't cancel. It's just the numbers inside that will cancel out. So you have it as root 1. Square root of 1 is 1, so you have it 1 over root 3, which is also root 3. Or since we know square root of 6 is square root of 2 times square root of 3, and we're dividing square root of 6 by square root of 2, you can say it over square root of 2. Since they are the same, square root of 2 cancels square root of 2. You'll be left with square root of 3. Same as this, square root of 3. It just depends on the technique you prefer. So you have square root of 6 divided by square root of 2 as square root of 3. So the result, which is square root of 3, you multiply it by the numerator, the number on top of it. That's 5. You have 5 times square root of 3, that's 5 root 3. So this is 5 root 3. We drag down this plus, then we have square root of 6 divided by square root of 3. We have square root of 6 divided by square root of 3. You can just say 3 here 1, 3 here 2. We can have this as root 2. You have to be very careful using this technique. So square root of 6 divided by square root of 3 gives you square root of 2. The result, which is square root of 2 times 3, that's 3 times root 2 is 3 root 2. We have this as 3 root 2. And since root 3 and root 2 are not like terms, we can add them. We leave it as 5 root 3 plus 3 root 2 over root 6. In short, you don't leave your final answer with root at the bottom. You rationalize it, and that will be taught in this series. This is not your final answer, but for the sake of just addition of fractions, we can leave it at this. Let us take a second question, and this time is subtraction. We have 5 over 2 root 2 minus 1 over root 3. Just like you do in addition and subtraction of fractions, you find the LCM. The LCM of 2 root 2 and root 3 is 2 root 2 times root 3. Since this root 3 has a 1 in front of it, you do 2 times 1, 2, then root 2 times root 3 is root 6. So the LCM is 2 root 6. We have it as 2 root 6. And you know we had to multiply this 2 to get 2 root 6. So if you divide 2 root 6 by 2 root 2, you get root 3. The result is root 3. You know the result is root 3 is like saying 2 times 3 is 6. So if you divide 6 by 3, you get 2. 6 by 2, you get 3. Same applies to this. If you divide 2 root 6 by 2 root 2, since you have to multiply 2 root 2 times root 3 to get 2 root 6, dividing 2 root 6 by 2 root 2 should give you root 3. Since the result is square root of 3, you multiply it by this 5, which is the numerator on top of the 2 root 2, you get 5 root 3 minus 2 root 6 divided by root 3 will give you 2 root 2. Since you had to multiply 2 root 2 by root 3 to get 2 root 6. So 2 root 6 divided by root 3 will give you 2 root 2. The result, which is 2 root 2 times the numerator on top of root 3, which is 1, will give you 1 times any number is that number. So 2 root 2 times 1 is 2 root 2. You should notice on the numerator that they are not like terms. This is root 3 and this is root 2. You can't subtract. At this point, this is not your final answer because you have a root 6 below. You have to rationalize. But we'll leave it at this because what we're trying to do at this point is to understand the subtraction and addition of SURDS in fractions. We have this further math question that says 3 over 3 plus root 2 minus 1 over 3 minus root 2. Leave your answer in form of a plus b root n, where a, b, and n are constants. This is a further maths question and it's quite easy. It's just telling you to work on this SURDS question in form of subtraction of fractions. We have 3 over 3 plus root 2 minus 1 over 3 minus root 2. Now, normal when we're working with fractions, we find the LCM. The LCM is 3 plus root 2, 3 minus root 2. multiply both of them together in this form. Then once you've done that, if you look closely, you see this is a difference of two squares. If you're a further math student, both of them have 3 in front, they have root 2's behind, then one is positive and one is negative. This is a difference of two squares. You don't need to work too hard to multiply this. Let's just go first with dividing the LCM by the denominator of the first fraction, which is 3 plus 2 root 3. If you take 3 plus 2 root 3 from 3 plus 2 root 3 in one bracket, 3 minus 2 root 3 in one bracket, this will cancel this. You'll be left with 3 minus root 2. So we have our answer of dividing the LCM by this first denominator as 3 minus 2 root 2. The result will multiply by the numerator, that's 3. So we have it as 3 into open bracket 3 minus root 2. That's 3 times 3 minus root 2. Then minus, you bring out the negative. Then the LCM divided by this denominator, this will cancel this. You'll be left with 3 plus root 2. The result, which is 3 plus root 2 times 1, will give you 3 plus root 2 in bracket. Note you put it in brackets because of this minus. This negative is very dangerous. On the next line, we open our bracket at the numerator, that's on top. We have this 3 times this 3, and 3 times root 2, or 3 times minus root 2, because this 3 affects this 3 and this minus root 2. Since this 3 is positive, it doesn't really cause any damage, or it's not really dangerous. So we just have 3 times 3, that's 9 at the numerator level. Then 3 times minus root 2, or you put your minus here. Then 3 times root 2 will be 3 root 2. Then we have minus, note there's a 1 here, so it's like saying minus 1 times 3, that's minus 3. This negative will not just change the sign of this 3, it's changing the sign of this plus 2 root 2 from positive to negative. That's why negative is very dangerous and you have to be very careful with it. So it changes it to minus root 2. If you had jumped on it and just throw away this bracket, you have minus 3, then this will be plus root 2, which will lead you to a wrong answer. Next, we know that this is a difference of two squares. The concept behind difference of two squares is a plus b, a minus b. The same thing as a square minus b square. Now, the a in this case is 3 and the b is root 2. So we have it as 3 square minus root 2 square. At the numerator level, we collect like terms. We rule our line, 9, then this 3 owns this minus 3, then you have minus 3 root 2, minus 3 root 2, then behind you have minus root 2, we collect like terms. Below, at the denominator, you have 3 square as 3 times 3, that's 9, minus, here you have root 2 square. Square, we cancel the square root, you'll be left with 2, so 9 minus 2. On the next line, we have our LCM line, we work on the numerator. 9 minus 3 is 6. Then we have minus 3 root 2. This 3 root 2 owns this negative. Then minus root 2 or minus 1 root 2. You pick out one of your root 2s. Then you have minus 3. It's like saying minus 3 minus 1. You're owing 3, you're owing 1. In total, you're owing 4. That's minus 4. At the denominator level, you have 9 minus 2. That's 7. Now, remember, the question says it wants the answer in form of a plus b root n. Now at this point, when you have it like this, you can't just cancel out. What you do is, since the 7 is dividing both the constant, which is 6, and the SURDS, which is minus 4 root 2, you give them their separate 7. Or you say you divide them by their separate 7s. So you have 6 over 7 minus 4 root 2 over 7. Once it's division, you can do it like this in math, or in further math, it's allowed. By the time you find the LCM of 7 and 7 and subtract, you still get this back. So it's allowed to have it like this. In form of a plus b root n, you have it as your a as 6 over 7. This is your a. Your b as minus 4 over 7. This is your b. Then your n, which is under the root, which is 2. N is 2. This is a question also gotten from a further maths textbook, where you have simplified without using table a square, where you have the question as 1 over a equals root 2 minus 1 over root 2. We say 1 over a equals root 2 minus 1 over root 2. We are asked to look for the square of a. We have to find a first before we square it. On this side, we can say this is root 2 over 1. Find the LCM. LCM of 1 and root 2. LCM of 1 and any other number is that number. So we have it as root 2. root 2 divided by 1, any number divided by 1 is still that number. Root 2 divided by 1 is root 2. So you have it as root 2 times root 2, which is root 2 times root 2. Root 2 times root 2 is root 4. Square root of 4 is 2, so we have it as 2. Then you have minus. Root 2 divided by root 2 is 1. Any number divided by itself results in 1. The result, which is 1 times the numerator, which is 1, is 1 times 1, that's 1. We still have our 1 over a on this side. Then we have 1 over a equals 2 minus 1, that's 1 over root 2. Now that we have this, we can choose to cross multiply, or we flip the left of the equals to sign and also the right of the equals to sign. It's still the same result. You can see a over 1 is same thing as root 2 over 1. Anything over 1 is that number. It's like saying 2 over 1 is 2. So a over 1 is a equals root 2 over 1 is also root 2. But the question says, what is a square? A is root 2, so a square is also the same thing as root 2 square. A square equals, square root cancels square. You'll be left with 2. A square is 2. That's the answer to the question. Multiplication and division of surds in fraction. This is an example of multiplication and division of surds in fraction. Let's say we have root 2 over root 8 divided by root 2 over root 6. Just like dividing normal fractions, so applies to this case. What we're simply going to do is to turn this division sign into multiplication sign and also flip the fraction behind. The root 6 takes the place of the numerator while the root 2 takes the place of the denominator. So we have root 2 over root 8 times, you've changed this division sign to multiplication sign, then you have root 6 over root 2. You flip the fractions. You can choose to convert this to basic form, or you can cancel out without converting it to its basic form. And if there is a need for you to convert it, you can convert it at the answer point. Let's just go on and solve this. Let's start with this. This root 2 cancels this root 2. Then with this root 6 and root 8, you can take 2 out of 6 and 2 out of 8. 2 out of 6 is 3, 2 out of 8 is 4. This root 2 turns to 1 and this also turns to 1. So you have 1 times root 3, that's still root 3, over root 4 times 1, that's still root 4. 4 is a perfect square and square root of 4 is 2. So we have this as root 3 over square root of 4 is 2. Our final answer is root 3 over 2.